In this video, we're going to solve equations containing exponential terms. To show how to solve equations containing exponential terms, I'm going to solve this equation 4e to the 0.02t power equal 100. And our exponential term here is e to the 0.02t power. Our first step is to isolate that exponential term. So we want to get e to the 0.02t power by itself on one side of equals. And we do that by dividing both sides by 4. So we get e to the 0.02t power equal 25. Now we want to turn that exponent into a non-exponent. Well, we do that by logging both sides. And when you log both sides, you want to match the base if you can. Here we have a base e exponential, so we are going to use a base e log, which is our ln log. So we take ln of both sides, and now that is going to allow us to move that exponent out front. By our exponent rule for logs, we move the 0.02t out in front, and we get 0.02t times natural log of e equals natural log of 25. Now natural log of e is log base e of e, so ln of e turns into 1. So this equation simplifies to 0.02t equal natural log of 25. Now we can use algebraic methods to solve this. In this case, we just have to divide both sides by 0.02. So we get an answer of natural log of 25 divided by 0.02, which to 3 places is 160.944. But for exponential and log equations, we always have to check our answers. So we have to plug that answer back into the original equation. And we get 4e raised to the 0.02 times 160.944. And on our calculator, we get 100.000418 out to 6 places. And that's very close to 100. It's close enough. That shows us we have an answer that actually works in our equation. Now we're going to do another example where we have an exponential in a fraction. We have 4 over 3e to the x plus 1 equals 7. Well, our first step is the same. Get e to the x all by itself on one side of equals, which means we are solving this equation for e to the x. There are different ways of doing this, but I think the easiest way is to start by subtracting 1 from both sides. We get 4 over 3e to the x equals 6. Now multiply both sides by 3e to the x, and this gives us 4 equal 18 times e to the x. Then divide both sides by 18, and we get 4/18 equals e to the x. Now we can solve this by logging both sides. Again, since this is a base e exponential, we use the natural log. We get natural log of 4/18 equals natural log of e to the x. And by the exponent property, we can move that x out front. And once again, we have ln of e turning into 1, so we have ln of 4/18 equals x times 1, which gives us a solution of x equals natural log of 4/18. To check this answer, it's easiest to write this as a decimal first, out to 3 or 4 places. And in this case, we wanted 3 places, so I have an answer of negative 1.504. I plug it back into the original equation, and you get 4 over 3 times e to the negative 1.504. Add 1 to that, and what we end up with on the left is 6.9995, which is close enough to 7 to verify that we do have an answer that works in our equation. So we write our answer either as x equals natural log of 4/18 or in decimal form x equal negative 1.504. In our next equation, we have 4 to the 3x plus 1 power equals 7 to the x power. Our exponentials are already isolated, so our first step here is going to be to take logs of both sides. I'm going to use base 10 logs here, although we could use base e as well. It doesn't matter. We don't have a common base on both sides, so use whatever base you want. But base e or base 10 will allow you to use your calculator to get a decimal answer. So I take base 10 logs of both sides, and that allows me to move those exponents out in front. So we get 3x plus 1 times log of 4 equal x times log of 7. Now we just need to solve this equation for x. And we can do so by distributing out the 3x plus 1, and we get 3x times log of 4 plus 1 times log of 4 on the left side. And we have x times log of 7 on the right side. And I'm going to rewrite this, so I have 3 times log of 4 times x plus log of 4 equals log of 7 times x. That is putting the coefficients in front of x the way we are used to seeing. Now we want to get all the x terms on one side and the non-x terms on the other side of equals. And we do that by subtracting log of 7 times x on both sides and subtracting log of 4 on both sides. This gives us 3 times log of 4 times x minus log of 7 times x equals negative log of 4. Now we can factor the x out on the left side, and we get x times the quantity 3 log of 4 minus log of 7 equals negative log of 4. We're almost done. All we have to do is divide both sides by that quantity. And we do that, and we get our answer of x equals negative log of 4 over 3 log of 4 minus log of 7. And now to check this, the easiest way to do it is to find the decimal form of our answer. And in our calculator, we get negative 0.6264, so we plug that answer in for x in our equation. And when we do that, we get 4 raised to the 3 times negative 0.6264 plus 1. And that gives us 0.2956. And when we take 7 to the negative 0.6264, we get 0.2955. That's close enough to tell us that this is an answer that works in this equation. So our answer of negative log of 4 over 3 log of 4 minus log of 7 is correct. And if we wanted the decimal answer to 4 places, then we'd use negative 0.6264. What if we were to use natural log instead of base 10 log? Well, it turns out that natural logs would have given us the same answer. So the answer of negative ln of 4 over 3 ln of 4 minus ln of 7 would also be correct. Keep this in mind when you're doing problems in the book. You may have used a base different than the book, and they have a different answer in the back of the book. But if it is a problem like this, and you used a different base log, and everything else is the same, then you have the correct answer.